Hi everyone! In this video we're going to look at the interquartile range and see how we can use it to identify outliers. So I'm going to be using this sample data set that was generated by ChatGPT. So these numbers are supposed to represent the number of hours different customers spent using a software during its 30-day free trial period. So we have a list of 21 values ranging from 1.5 hours to 20 hours. In my video about the 5-number summary, we calculated the 5-number summary for this data, the min, quartile 1, median, quartile 3, and max values. For this data set, those are 1.5, 3, 4.8, 7, and 20. And we also generated a box plot that I'm showing at the bottom of the screen here. So the box whiskers range from 1.5 to 20 on the number line. And then the box itself goes from 3 to 7 with a median marker at 4.8. So the IQR, or the interquartile range, is based on the range between quartile 1 and quartile 3. In this case, that range is from 3 to 7. If we actually calculate the IQR, that would be 7 minus 3, or 4. And that range of values represents the middle 50% of data. So 50% of the users of that software trial had used the software between 3 and 7 hours. This is sort of like the range, but just for that central 50% of the data. So the IQR is a good measure of spread that focuses on typical data values, sort of the ones in the middle, versus the range, which really only looks at the extreme values, the min and the max. So if you were comparing the spread of different data sets, you might consider the range as well as the IQR to get a sense of how spread out is the data overall from the min and the max, and then how spread out is the that middle 50%. Once we have the IQR, one thing we can do with it is to use it as a guideline for identifying outliers. So there are different possible ways to classify outliers, but one common method is by taking 1.5 times the interquartile range and saying that any value higher than quartile 3 plus that amount, or lower than quartile 1 minus that amount, will be outliers. So for this example, our interquartile range was 4, that was the 7 minus 3. If I take 1.5 times that interquartile range, or 1.5 times 4, that gives me 6. And then I'm going to take that 6 number, 1.5 times the interquartile range, and I'm going to subtract it from quartile 1 and also add it to quartile 3. So my quartile 1 value was 3, that's represented by the left side of the box. If I subtract 6 from this, it gets me over to -3, which is off my number line here. That would be somewhere over here. So any values less than that would be considered outliers. Now, you can't really have a value less than -3 in this context. This data set has no lower outliers. But on the upper end, if I take quartile 3, which was at 7, and add that 6 number, that was the 1.5 times the IQR, 7 plus 6 is 13. That takes me to right here on my number line. And any values above 13 then would be considered outliers. In this case, there are some outliers in the original data set. So considering those fences of -3 and 13, if I come back to the original data values, I see that the lowest is 1.5, which again is not less than -3. And then if I look through the data values to the high end, 14 and 20 are both values higher than 1.5 times the IQR. So those would both be considered outliers in this data. Now, however you're classifying outliers, you need to consider them carefully. You might look at, if you have really extreme outliers, if they were some sort of error in measurement possibly, or do they signify something significant? So in this case, this means that these two software users used the software a lot more than most people did in the free trial period. So maybe you could find out what they were using it for, or whether they purchased it or not, or even if there was some sort of problem with how it was tracking usage numbers or something like that. But just something to investigate to see what the meaning is in those outliers. That's it for this video. Thanks for watching.